Hi everyone. How are you doing? Welcome to day 30, and it's just exciting, like really, really exciting. Uh, it's been kind of wonderful experience, you know, learning Python for. I think this should be our the. If we talk about the number of classes that we've had, it's about 20 classes. Okay, consider the fact that our classes run through Mondays to Friday and some holiday in between. But the idea is this: is that I shared it on the Slack channel. The number of topics that we've studied, and just one topic was not in it, and I want to do that today. All right, so that would be Python, NumPy, or arrays. So the reason why I have to do it, I know today I said I was going to talk about Git, but it's not really Python stuff. It's something you can just read about and you know get to understand it. But I want to talk about NumPy because I feel like if we don't introduce this topic, those who want to go into fields such as data analytics, data science, with Python, they might not actually have this concept. All right, so touch more about web and the rest. So, well, let's just do a little bit on this because after NumPy, the next thing that you want to think about if you want to do data analysis is you have to now study the pandas modules and then start for visualization, matplotlib, seaborn, plotly. Okay, you start going through there. Then maybe to machine learning, where you have to read about classification and regression, study the models, and okay, from there you might want to move into deep learning, or you want to move into big data, or you want to move into NLP. So you have to study things like PyTorch, TensorFlow, um, Hadoop, Big Stack, those stuff and all of that. Start studying them to understand how to work with data. All right, so let's do this. It's going to be very, very interesting. Now, first of all, I want to say that Python, NumPy, it's similar to Python list, but it's different. Okay, it's similar to Python list, but it's actually different. Okay, so um, normally Python objects, a list is an object, so it has a high level number of objects, integers and float points. Containers, we have list, costless, intersection and append, dictionary, fast lookup. So this is more like what are Python's objects. We have things like integer, floats, and then we now have containers like list, tuple, set. This, so you get the idea. But the difference in between which we're going to extract is just we're talking about list. So we can basically do little with our list. All right. Good evening, everyone. Good evening, Wisdom, Francis, Flora, and the rest. Welcome. So we can basically do some stuff. For example, append, extend, count, index, do some slicing and all of that. But we want to carry out some computations in our list. Okay, it can be very, very difficult. For example, if we want to do the sum of a list, we have to either use the sum function to get the sum of a list. If we want to get the maximum number in a list, we have to use the mass function to get it, and also need the me function to get the lowest number. So we have to use a function to be able to do all of that because as a list, it does not have the strengths, or let's say it does not have the objects or the methods to be able to get those answers. But then that is where Python NumPy comes in place. Now NumPy is faster than a list. Okay, when we say a list, it's faster than the normal Python object list. It's faster. It has a lot. There's a lot to the NumPy package that you guys have to study. Okay, you can't cover that in one class. I, for one, when I started learning NumPy, I always tell people that NumPy was one thing that I was like, "What is this?" All right, but I had to take time, go through it, go through the. If even right now, I still read the documentation. Let me see if I can put that one up. NumPy documentation, and also Python has a documentation. Let me see if I can share that part of my screen that shows. Okay, so share screen. Let me just share my entire screen, so I don't need to move from one place to another. Okay, great. So this is it. Guess you guys can see my screen. So this is it. So you see NumPy documentation. You can click on it, and we get to read about all you want to do on NumPy. So the manual, web, latest development, documentation for enhancements, and all of that. Then let's click latest development documentation. Okay, so they have PDFs and all of that. So you can always come to their website and absolutely guide for beginners. Great. So this is how to import NumPy. Reading the example. Why use NumPy? Python lists are excellent general purpose containers. They can be heterogeneous, meaning they can only contain elements of variety of type, and they are quite fast when used to perform individual operations on an element, depending on the characteristics of the data, typing operations that needed to be done, blah blah blah. NumPy. This is where NumPy shines when there are large quantities of homogeneous same type data to be processed by the CPU. So that is the difference. A list can have different data type inside of it, meaning that they can do variety of tasks, right? But NumPy shines where you have the same data type. So when you have the same data type in a NumPy structure, it's fast to be processed in the CPU. Basically, we're already reading this thing here on the computer programming. Array is a structure of storing and retrieving data. We often talk about array as if they are grid in space, which blah blah blah. So yeah, great. So you could see the way we even stated it. So this is more like a list, and then we pass it into a method called array from our NumPy module. So let's just go back to our code and see how we can. So most of these things I'm going to talk about already here. So importing CSV and importing. So you can even use NumPy to be able to do that. So this is pandas. Yeah, great. Fantastic. So once in a while, it's always good to always come to the user guide to learn about documentation. Also, I think even Django. There's nothing that we Python Django. Everything has the documentation. Documentation. Okay, so Django documentation. Now, I think let me zoom in so that you guys can see what I'm doing. So the issue is that most of us, uh, you want to ask yourself that before the era of generative AI that most people are running to, what would they use it to program? Reading. Okay, you read, and all of this has documentation. You can search for the documentation, how the document is structured. So let's look at tutorials. You can click on tutorials, Django at a glance. This is how Django at a glance looks like. Remember what we did yesterday and all of that. Module for database. These are database. So you install it, you save all the things that you need to save. So you can follow step by step what is listed on this website, and you can be able to get a practical Django website framework. But let's go back to our NumPy. That's what brought us here. So this is a list. Let me select a color. So this is a list. We have first list that has 1, 3, 4, 6. And then we have another list that has 1476. Okay, 78. So what if we want to add these two lists together? If I run it and I say first list plus add, we're going to get an extent of that list. So when you do plus, when you plus two lists together, you extend it automatically. Okay, that's what you're doing. But it's different when we come to NumPy. So extension package to Python, we've read about what NumPy can do, designed to for scientific computation, also known as an array oriented computing. So we import NumPy using import NumPy as NP. Now, when it comes to things like NumPy, pandas, and some kind of importations that we do, there are traditional ways to which Python in the community accepts how you alias these packages when you import them. For example, NumPy is NP. It doesn't mean if you say you want to import NumPy as PY or UNU, it's going to work, all right? But traditionally, NumPy is NP. Don't make that mistake, all right? Pandas is PD. So there's this funny joke that if you want to confuse someone, coding, especially in the data analytics world, what you need to do is to import NumPy as PD and import pandas as NumPy. The person is going to like, what is going on here? Until you get to the code that's check the error message very well and find out that maybe it might be type error or the method is not available or the attribute is not available. Then you now have to ask yourself, what type is this uh, variable or this object I'm working on with? So it's always good. Tradition, always good. NP. So we port it. So no module found. So what's happening here is that my kernel cannot find this module. So I'm going to do something like just dash first and to Python function. I don't know which Python version I'm using. Python 3. Sorry, I'm using my Linux command. Okay, great. So now just to pip install NumPy. So these are your install packages. All right, like I showed you guys yesterday, we were working on Django. So use the pip package manager to be able to install most of these packages that are not there on your Python. When you install Python, they don't come with it. Okay. Sometimes there are some things you install that installs other things. For example, if I'm going to say pip install pandas, pandas will take NumPy as a dependency. So pandas is going to install NumPy alongside. All right. So I didn't know that that was not working. So we have to just wait a bit for my network. I hope it's not as slow as I'm thinking because it's kind of slow a little bit. So while this is going on, I would love to be explaining. So I think I already have the answers, but I would just love to explain. So let me. Oh, this is kind of slow, really. Just thinking. So while this is going on, I don't know. Maybe. Uh, okay, let's do something. Let's collab. Collab. Research collab. Okay. I think I have this on my Google Drive. I don't know if I have this on my Google Drive. I want to use Colab to just do what I'm doing. Let me browse. Let me browse mine. I don't think I have that time to be waiting for that to happen. So I'll just go here, home, GOC, Python tutorials. That should be NumPy, and just upload it. Let me see if this one is done. It's taking a lot of time. It's taking a lot of time. So great. So let's just go with what I have here. So in this case, I'm going to connect. So Colab, for those of us who've not seen Colab before, is an online platform that Google created for you to run Python Jupyter Notebook scripts. Okay, it just works on your browser. You don't need to install anything on your system. All you need is just to connect your Google PC. This is our Google account for PIP community, and then voila, we are able to do what we need to do. So yeah, I don't need to install NumPy because Google has a lot of packages that it has installed. All right, so I'm trying to see I can show you that if you do something like pip freeze. I don't know if that will take a lot. It will take a lot of time. So this is how you find packages available on maybe your browser or your desktop or something. So you can see that we have a lot of stuff that has been installed by Google Colab. So there's a lot here. So you could NumPy is here. Let's move to where we have N. So they have PyClip. PyClip is the copy. If you want to create a copy button with your Python project, and a lot of stuff that they have here. Okay. So I'm just trying to show you that they have NumPy already. So this is NumPy, and this is the version. What you see equal to, or some what it's saying is that this is the NumPy version that they have. 2.0.2. This is the version that they have. Great. So let me, where's that script again? Comment it and just run it. Great. So I'll cancel this one running at my, let it just be running. It doesn't affect me. So we import NumPy as NP. Now what we're going to do next is that we're going to create our first NumPy array. And how we're going to do it is that we're going to say, okay, NumPy, first NumPy or first is equal to np.array. And then this is a method we are calling from NumPy, all right? np.array. Then we'll pass in our list inside. So when we pass in our list inside, it's going to convert that list into a NumPy array. So we'll do that for the same second. And when we are done, the next thing we're going to do is that we're going to add these two lists together, these two arrays together, first and second, and then print the result. So you could see that what we have now is that rather than having something like this where it embedded them, it actually summed the value and it summed them on vertical wise, right? Yeah. So 1 plus 1 is 2, 3 plus 4 is so 7. So we call it element wise. So it's adding them based on their rows. All right. So 1 plus 1, 2, and all of that till we get 14. So you see that this is very, very easy to achieve something like this. If you want to do that for um, for a list, if you want us to do this thing for a list, we are going to run a for loop to achieve that. All right. So we run a for loop that captures the first item here, plus it with the first item here. This capture the second item here, plus it with the second. So that's how we are going to be. We are going to look through it. Okay. But for this thing to always work, they must be of the same size. What if I make here 10? Let's run it and see. See, we're going to get an error. Operands could not broadcast together with shape because they are not of the same size. So if you want to do things like this, you must be careful with how you do your stuffs. Okay, they must be on the same size. So why it is useful? Memory efficient container that provides fast numerical operation. So this is we trying to create a list comprehension using a normal list. Okay, so we want to do something like we'll create a range of 1000, save it into air. So air becomes literally something we can iterate over, a value we can iterate over. So we say for I in our L, we want to increase I by 2. So we want to find the square of I. So to run that, we're going to trap the time it's taking us to achieve that. So this is it. So this is the time it took us to achieve that. 10,000 loops each, 7 runs, and 63.3 seconds plus 823 ns per loop. Okay, so this is the speed it took for this code to work. Or let's say this at this time now we are using NumPy. NumPy has its own range, but it's called a range. Okay, so a range is the same thing for NumPy. All right, and you can see that this is quite slower. That's quite faster. Sorry, compared to a normal list, and the loops that it ran is even more faster compared to the normal list. So NumPy is just a test and show you that NumPy is kind of a bit faster than a normal Python object when it comes to performing some task. For example, if you want to sum all the value in a list, all right, for Python, you have to run a for loop, but for NumPy, you just use the method to sum it. So there's what's called dimensions of arrays, all right? When you begin to, you have things like one D dimension or 1D, 2D, 3D, and all of that. So a one dimension array, we call it a vector. It means that it's just an upper array that has numbers, or values sequential, just listed in rows, all right, or listed inside the NumPy array, but it has just one enclosure. So, for example, this is a one-dimensional array. Okay, so if I run it, and we can also use type to get to know what it is. So this is a one-dimensional array. I want to see why I'm bringing this up here at the moment. But let's go up. I think I also explained it. I think I explained it below, but I don't know why it's there. Maybe I was trying to explain something to previous class or something. So, okay, let's say we have a list now that has this set of numbers. I said if we want to sum this list, we have to go through. We have to go through. What do I call it now? Loop to be able to get the mean. Okay, let's say we want to get the mean of this list. We have to go through a loop. So the first thing we need to do is that we'll get the sum and get the number of items in that list, and then add the all the numbers in the list, then divide it by the sum. So this is the loop that we need to run to get the minimum or the average, sorry, um, of a list. But to do that in an array, we just do the dot sum. Dot sum will help us get the initial sum of the lists. I think I need to do print here. Sorry, print. I take out some. Okay, so you see this is the sum, and then if I do what is the average, we just do dot mean, the array dot mean. So you can see that we got the same stuff. So no need running those SS code. You just get it easily. Okay, great. So we can also do the index. Remember index already. We can also use index to get. I think Google Colab has changed the way they do their things. I don't know why they're printing the type of box and the answer. Okay, we can also use index to get the values in the list. But one thing I want you to notice is that do you see that when you print an array, this is an array. Okay, this is something I just somehow I don't know. I just look at it and I felt like this thing is actually how I can differentiate it when I was learning. This is an array. Let me print our list that we created. I think we created list one or something. So this is a list. This is an array. What do you think is the difference in them? I'll just tell you because of time. The difference is that when you print an array, there's no comma separating any of the value. But when you print a list, there's a comma separating the values. So that's an easy way to just spot which one is an array and which one is a list. Okay, so you see there's no comma. After 11, there's a comma here, but after 11, there's no comma. All right, so we can also slice an array just the same way we did on a list. Now, the next thing we want to do is how do we create a two-dimensional array? Okay, I've talked about one-dimensional array. So this is a one-dimensional array. All right, and so we create a list, pass it inside the np.array, we make it a NumPy array. So if the NumPy has what we call dot shape. Now, the dot shape, the attribute shape is an attribute, not a method, because it does not have a parenthesis attached to it. So the attribute shape allows you to know the total number of rows and columns in an array, or even a pandas data frame. Okay, and even in TensorFlow and PyTorch. So if you check remember I said rows and column. So if you check the dot shape for a one-dimensional array, it's going to tell you that it has 12 rows. So what is playing here is that Python does not see this thing like 1, 2, 3. It does not see it on a straight line. It sees it. It does not see it horizontally. It sees it vertically. Okay, because it sees this as rows, not just something sleeping on the floor or something. It sees it as rows. That's why we're getting to it, because it's always rows and column. That is what shape will always give you. I don't know if they explain it. This guy didn't explain their own. My God, this thing is still installing. 16 MB. Something must be wrong. So we use shape to get the rows and columns. We can use reshape to change the way we want it to look like. Okay. So we want to change it from being a shape of 12 to be a shape of 3 by 4. So what we want to say is that give us 3 dimension of the arrays. Give us 3 dimension of the arrays, and then give us a 2 dimensional array, sorry, and add 4 elements inside. So if I run this, we've reshaped it, and yeah, I want to show you something. We reshaped it. I don't know why I'm having dimension of array coming here. Ah, my God, this thing is just, I didn't. So if I come here now and do something like new age, well, first of all, let me just print new age first. Let me print new age. So if we print new age still remains the same. So what we need to do is that we need to save the value that we have here into a new one. So I'll come back, I'll come down here and do something like new age is equal to new age dot reshape 3 by 4. Great. So if we print new age now, that's a new age dot shape. Dot shape. You see that the shape has changed to a 3 by 4. So 3 columns. How is it 3 columns? Let me print it out for you to know that it's 3 columns. Oh no. So 3 columns. So if we run it, you see that this is one row, 3 rows, sorry, 3 rows, 1, 2, 3. You can see now that we have two item of, let's say we have an outer list first. This is outer list, and then we now have list inside. You want to call this nested list, but in Python it matters because it can change the dimension of the array. So 3 by 4, 1, 2, 3, 4. Great. So I don't know why. So this is another type of way of declaring. Like I said to you, to look like nested list. You can see this is a list. Age is a list inside. This is a list inside a list. 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 All right. Well, this is more like this is 1, 2, 3, 1, 2, 3. So we have 3 rows. 3 columns, 1, 2, 3, 3 columns. Then if you count the number of lists inside, 1, 2, 3, 4, 5. So we have 5 rows, 3 columns. Because what Python is actually saying, is saying it like this. Let me show you guys how it's saying it. This is how it's saying it. Not that straight line that you think. It's saying it like a matrix. Okay? It's saying it like a matrix. Remember matrix now in school? That's how an array looks like. An array looks like a matrix. So I need to put comma here. It looks like a matrix. So this is how it's saying it. Good. So in this case, it says it's like, okay, you have 3 columns and 5 rows. So this is how an array looks like. It looks like a matrix. I just wanted to understand that. So we run this, And then once we print the shape, it's 5 by 3. Then, given the fact that, let me print the new age again. Let's print it rather. Let's say we want to access this value. Okay, let's say we want to access this value. All right, for us to be able to do it, what we need to do is that we would use index to get it. So use index 0 because that's the first item in the list. So index 0 will give us the top item there, right? Which is great. So the next thing we want to also check is what if we want to access, remember our list now, when we are able to get one item, can be able to go inside that list, and because it's a list, if I want to get 23 now, I can just index again and say 23 is at index 1 and I run it, so I'm able to get 23. So that's how you can index into multiple. Let me now check. Finally successful. It's okay, clear. We would leave it the way it is. Let's just do what we are doing. So this is how you can index. You can access multiple values inside. No, inside two-dimensional array. So I'll run this again. Let's say this is our new age. I want to get. I'll take this one off. I want to get. This is slicing now. I want to slice. If I do something like this, or it's going to give me everything. Okay. But if I do, I want to get from. Let me see if I already have that on the ground. Okay, now I have it on the ground. So if I do up to, let's say 2, it's going to filter it and give me the first 2. All right. Then if I say up to 3, it's going to do the same thing. If I say from 1 to 3, it's going to cut it. Let me see. Let me not do one. Let me do 2 to 3. So 2 to 3 is giving me 33, 37, and 20. Right. So it's just like it's giving me this. But what if I want to say, give me like, let me show you something. Let me say 33, and I'll say something like 1 to all. No, I want to do 1 to all. 1 to all. So you see, I put a comma. This way, slicing can get complex a little bit. So I want to get from 37 to 20. That's what I'm saying. That when you slice to this place, okay, you've given me all of them, fine. But I want to get the first index to the last one. So the first index that's the number one index. No, the first is only 0. Number 1 is the second item to the last. So you can do things like this. I can also copy this and say, we can say that I want to get all, give me all, then give me the -1, -1. So give me all, it's going to give me all of this, but I want you to give me -1 of all of it. So it's going to filter by giving me things like 34, 27, 20, 25. So what it's doing is that it's going to pick this array, all the arrays, but it's going to give me the last item in each of the arrays. And that's what I have here. So you can see that from a two-dimensional array, we've converted it to our result is now a single or a vectorized stuff, array or a 1D array. So we've talked about how to create two-dimensional array. We've talked about the shape, and I've talked about slicing. Talked about how to slice it and all of that. So it's the same thing. We've talked about how to get the shape of a two-dimensional array. Then another thing we can also get is that we can also get the D type of an array. Okay, I think I need to run something. Let me see if I run this, I will get an answer. Great. We can also get the D type of an array. So the D type of an array is like you want to know what is the content to which an array is having or is hosting. So if I have not clicked on metrics, let me click on metrics. Where is that metrics array just now? So I can be able to use it to do what I want to do. Good. So metrics contains. So we can also get the dimension of an array by not just looking at counting the distance. You can get the the dimension of an array. Game it with Dragon. If you have a question, you can just type it on the group on the comment section. I will always answer your question. So so the next thing we can do is we can say we use the n dimension to get what type of dimension is an array. All right. So we run this, and then it will tell us that it's a one-dimension array because come on now, remember it's just a one-line array. So I'm seeing the comments. Say, I have a question, just one UI. Hello, I'm leaving. All right, I've already told you to comment your question. It's fine. So we would go ahead. So we can also use the end time, um, attributes to be able to get the dimension of an array. So we just use end time to get the dimension of an array. That's what we do. All right, fantastic. So we talked about some of the elements in some of the elements or some of the methods that we have in NumPy. We can use dot sum to be able to get the answers to sum all the values inside. These are all the values inside our matrix array, right? We can use dot sum to sum all the items inside. It's going to sum every one of them. Okay. But also we can determine how we want to sum it. Do we want to sum row wise? All right, or we want to sum the axis that we want to sum. Do we want to sum row wise or we want to sum column wise? Okay, that's another way you can also do sum. So you can pass in the axis that you want to sum, how you want to sum it, or you want to get the sum. So you'll be able to get these values. Good. And then we can also use the dot mean dot mass to get the minimum and the maximum values inside our array. Oh, great. Same also, we have other attributes like mean, STD, variance. These are things that if you want to apply them on a list, it can be very, very difficult, all right? But you can also get to apply them on your array and you get your answer. Great. So before I do all of this, let me check if I'm not repeating them again. Okay, I'm not repeating them. So there are other basic stuff inside a NumPy array, things like there are methods like once. So what dot one once does is that it creates for you a NumPy array that you can easily just that has one or throughout. Okay, it has one or throughout, so you can run it. So if I do np.once, pass the number of rows and the number of um, columns that I want, it's going to populate that for me. If there are ones, there are zeros, and it does the same thing. And you know that this is a two-dimensional array, all right? But then we have np.I. So what it does is that it creates a two-dimensional array for you, but the positive values are placed on a diagonal paths like this. So that's how you have it. We've already checked the dot shape to get the shape. We've talked about the dimension to get the dimension. We talked about the type and all of that. So we also looked about reshape. We've done the reshape. I showed you guys how we can use reshape to change how a NumPy array looks like. Then we can talk about add addition. We can do computations on our NumPy arrays. For example, what we have here is that we want to do an element wise addition. Addition is what I want to do first. Addition. Before I did that one to explain to students. So we want to add these two arrays together, which we've already done before. You've seen it before. We've added. We can also do division. We can do multiplication on the same parts. And yeah, very, very awesome. We can do that. Someone says, I have a question, so for explanation. Is that the least different one? Where the commas everything around the platform is still have comma inside of the matrix. Or is it we have comma inside of the matrix? Let me go. So this is a metric, but I don't see any comma inside. Kisley. This is a matrix. I don't see any comma inside. And I think you are speaking to the parts where I was doing. There was a part where I don't know if I can scroll up to that place again. This is a list. If this is what is confusing you, this is not a metric. This is a list. I just broke the list down. So this is a list that we passed into a NumPy array, and then by the time when I run it, let me show you. So print this. So let me print this. If I print it, you will know that. So print h. So you see, there's no comma. Don't mind the code, the ID, because I ran only h like that, so it brought this stuff. But you print a number, you don't comma. But it's just a way for you to be able to know easily that what I'm saying is that's just to the eye. But the best way to do is to use type, right? For example, there's difference between this one and this other age. Okay, they are two different things. So always use type sometimes. So I'll come back. So I think I was at vector vector arrays. Okay, so we're talking about vector array. Let's say we have an array of salary type. There's an array of salary. When you do data analysis, you find out that I always tell that every column, yes, every feature is an array. All right, it's an array. So that's one way you can be able to manipulate arrays or manipulate data. If you understand that this is an array and it's a vectorized array. Okay, so and I'll tell you guys this: every table is a two-dimensional. Every table is a dictionary. Okay, those when you do pandas, you understand that concept. Okay, so let's say we have a vectorized array or a vector of this value salary. Let's say these are the salaries. If we want to minus 200 from each person's salary, okay, we can be able to, all right, well done, Kisley. So we can be able to just say salary minus 200. And once we run that, it's going to it's going to minus all the salaries, 200 from all the salaries that we have in the data in that array. That's how fast it is. You can't do this on a list, right? For you to do this on a list, you have to run a for loop. So say for each item in the list, minus 200. You see, that will take a lot of time. What if I have 1 million, or let's say what I have 5,000 or 10,000 numbers in the arrays of salaries or whatever? How do I, before the loop finish running? That's a lot of time. So if you can do minus, we can also do something as we want to want to give everybody discounts. So the discount is your salary multiplied by 0.2, that's 20%. I want to give everybody 20% discounts, bonus rather. So salary times 0.2, whatever we get there, plus it with our salary. So if you run this, it's going to reflect. Okay, great. So just trying to check what other things that I need to teach you guys. We've done all of these things. You can divide it to array. Great. So the last one I want to talk about is Boolean. Is it Boolean? I don't know. Maybe there are other topics. So Boolean, it's I need to run something so that I can get this array that I want to use for Boolean. Good. So Boolean, what Boolean does is that it gives us the ability for us to be able to extract extract results. Remember we're doing filter. Remember when we did filter in Python? When we said filter, with filter, it will go through your list and extract what is true and present it out. That's what Boolean is doing. Okay? Same thing like a filter. When we mapped a function, or we did lambda also. Wow, we did a lot. So we did lambda. So we use lambda to apply something, then use map to map that function, all right, on a list, and then we use filter to filter out And the item that is based on the condition that we are given. Guys, go and watch those videos. They're very, very important. So what if in a array we want to get all the elements that are greater than 4? If I run this, I'm going to save the answer into feet. So let's print feet. So this is what we're going to get. Feet is going to give us false, 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 true, true, true. You understand? So it's going to give us the answers that are false, the ones that are true. Now, if we want to get the result out, what we need to do is just pass our filter, what we have what we've saved this false, false, and true. Pass it as we want to access it at like the index. You want to access it like these are the index on your array, the same array that we applied the filter on. Once you pass it like that, it's going to give you the right answers that are true. All right, so don't get confused because you're saying, just know that this is array, right? It's array. So don't be confused by this comma. Right, I just showed you guys that one. So if you pass it like this, you get the answers that are true. What if you want to get the answers that are wrong? Remember when we did nots? Okay, so when you move from NumPy and pandas, this is how they represent nots. Nots is represented with this symbol. This is not. Let me see if I can. This is. Let me go back to this place. So this is not. This is an. This is or pipe. This is how when you another concept in Python. These are they represent not and or. All right. Python objects is this not and or. But once you go with pandas NumPy, this is how you present your not and or. Fantastic. So just comment this one here. So this is not. Oh, I even have it down. See me. I need to go down to my notes to see. So this I have it spelled out already because I know if I explain this, I was going to show you guys how it looks like. So in case you see someone using this, you don't get confused. All right, you already know what they're doing. This is why I said I needed to teach something like NumPy today. So we can also filter, even if we decide not to put the condition inside a variable, we can put it, we can write the condition, right, or the filtering inside our array, index it, we'll get the answers that are true. And we can also apply the AND operator. So give me values that are greater than 3 and values that are less than 9. So run that, we'll be able to get the AND. We can use the OR and all of that to get what we want. Let me see, new array name does not. Oh, sorry, it should be array 2. array 2, array 2, array 2. That's how we get the answer. Okay, so we've talked about a range. I've talked about a range. Like just say we Python has range. Python object has range. NumPy has its own called a range. So you can use a range to generate sequence of numbers too. And for a range, you can also access. Python has other things like random. See, there's a lot in Python. Python has what you can use to generate random numbers. Remember when we were doing bank app? Okay, when we're doing bank app application, there was a part where I showed you guys where we generated a random account number. Python has the ability to generate random random number, and you can also tell it the size to which you want to generate the random number. Let's say I want to generate 4 random number, or maybe somebody signed into an application. You want to send the person 4 random security code. You can use NumPy to generate those 4 random numbers and send it to the person to verify. Okay, so that's the idea. I'm just telling you that those things are just there. Sorry. So we can create a random int of 100 and it's just going to be very, very long or whatever. But great. So what I'm doing here is that create numbers between 0 to 100, but make it a size 10. So that's what we got here. All right. I think we've done things like this, percentage. So this is the same thing as you are doing filtering. So we want to filter in the age, which of them is not even numbers, and all of that. We can get that there. Now remember the copy. It also works with Python. Okay, if you want to copy a NumPy array, um, don't do something like a is equals to b. Don't try that. Just do use the copy function to be able to copy. We did this in list, and we did that in I think we did that in list and dictionary too. So please always use the dot copy if you want to copy one value to another place. Yeah, so this is how far I can go because of time, but there's a lot in NumPy that we can learn, and I've already showed you guys where we can come to be able to learn a lot. You can see from this place, um, there's a lot you can learn from NumPy. Okay, so fantastic, guys. Switch to stable action for these documentation of stable actions. You can switch to stable action and learn. So this is where we would say we've come to the end of our class, and probably also the end of lecturing. I'm so excited, guys, that this was fun, and I know you guys learned a lot. So let's build more on what we've learned, and at the end of this training, we're going to offer you guys. We're going to give an open project and drop it on the Slack channel for everyone to do to practice, and then you submit it to us. Our project it's very 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 simple. It's just going to have a whole 1 week to do it, and then you submit it to us. Very very simple. I will suggest that everybody participate in that project. All right. So that being said, guys, let's meet at the Slack channel. See you guys. And from me, I would say thank you for hearing my voice. It's been an awesome time hearing my voice, like an awesome time hearing my voice, and I'm excited. All right, guys, I'll catch you later. Bye.